Hello, this is Dr. Hui Liu from San Jose, California, United States. My email is ibridgepy@gmail.com. IBridgePy is an easy-to-use Python platform to help traders to build algorithm trading robots. It can backtest and live trade with interactive brokers, Robinhood, and TD Ameritrade. You can download iBridgePy from www.ibridgepy.com. Please don't forget to subscribe to the channel because more tutorials are coming.
In this tutorial, I'm going to talk about IBridgePy Backtester new features. And right now, IBridgePy Backtester is much easier than previous versions. We have a few tutorials talk about using IBridgePy Backtester without specify historical data or load from local files. And this time, the goal is to speed up backtesting by designating spot times going through the backtester. The motto is backtest only the spot time that strategy needs. Specifically, we will talk about the strategy we're going to test is buy low, sell high strategy. In that strategy, the real transaction happens on 3:59 p.m. Eastern Time. And other simulated times, even if it goes through the simulator, will be ignored in our strategy. We will talk about that in the strategy. So which means if the backtester, we only designate 3:59 p.m. in backtester and only test those spot times, the backtester will become much faster. So in this tutorial, I'm going to talk about how to start a backtest. Include pick a start time and end time, supply historical data from local files or from brokers as needed. And then the critical part is to create a list of spot times going through the backtester. It depends on the strategy. So after demo, we'll talk about pros and cons. And then we will talk about how to improve this setting in the future. Also, I will introduce the related tutorials to help you better understand the topics in this tutorial. To the code and give you a real-time demo about backtesting in IBridgePy. So first, I would like to talk about the strategy we're going to backtest. This strategy is called close price reversion. And this strategy is very simple. The basic idea of this strategy is if yesterday's price is higher than today's close price, which means there is a price drop at the end of today's trading day before market close. If there is a price drop from yesterday to today before the market close, then we assume there is a price reversion, which means tomorrow's price will go up. Then at this moment, before the market close, we place an order to long the position, which means we want to buy. And in this strategy, we want to buy 100% of the portfolio. If today's price is higher than yesterday's price, which means there's a price jump, then we think it's time to sell off our portfolio. Because yesterday there's a price jump and we got benefit, then it's time to sell. This strategy is here. There are two basic functions. One is initialize. In this function, we define shared variables in IBridgePy. So we have a variable called context.security to define security, which is the ticker is SPY, which is ETF to track SP500 index. We use SPY as a demo. And there's a IBridgePy function called schedule function. This function is in IBridgePy is to schedule other functions to run at specific time. In this example, it takes 3 variables. The first one is called daily function actually, and this is the function name. We define daily function name here, which means we want to run this schedule to run this function at some time. And there is a date rule and a time rule. The date rule is what day you want to run this strategy, want to run this function. The day rule is every day, which means every trading day because weekend we don't trade. And the time rule defines when in a day you want to execute this function. And we said we want 1 minute before market close. And this is the time rule. So which means this function will be triggered 1 minute before market close every trading day, which is 3:59 p.m. Eastern Time, because the US market closed at 4 p.m. And we assume the price at this moment will be very close to the real close price. And daily function is the function where the trading decisions are really made. So first, we print out the time when this function is triggered. So we use an IBridgePy function called getDateTime. And then we request historical data. Because we only need a daily bar and we only need yesterday's price, so we request historical data of SPY, and we want daily data. We want to go back 2 days. The close price is this. Yesterday's close price is this, and today's close price, even if the market is not closed, but we assume at this moment the price is very close to close price already. If close price today greater than yesterday, we want to sell. So we use an IBridgePy function called order target percentage. Otherwise, we long this position. And this is the strategy we are going to backtest in IBridgePy. Before we start to go through how to backtest use spot times, I would like to quickly go through the previous tutorial talk about Backtester, because by going through the previous tutorial, you will have more understanding why we are talking about spot times. I mean the backtesting using spot times. The first setup is called test me easiest no hist injection. In this backtest format, there's no historical data is required because we say data provider is interactive brokers, which means every time IBridgePy needs historical data, it will send a request to interactive broker servers, request historical data back, and complete the backtest. The pros of this test is it's very easy. The setup is very easy. The cons is the backtesting takes a lot of time because the data goes from request goes to interactive broker server and come back. So the problem is the backtest is slow. Then we made some improvements by supply a historical data ingestion plan in test.me file. In this file, we ingest historical data, not request as needed, but we request before backtesting as a batch, which means we request historical data together before backtesting. So backtesting become much faster, and it takes time to request historical data from broker. So we improved by adding HistIngestionPlan. Also, we switched to the next tutorial, which is to load historical data from third party by loading the historical data from local file instead of request data from interactive brokers or other brokers, so that the data provider we are using is a local file. And because we supply data and we can use any historical data from any data provider or data sources, so the backtester become much more flexible for users to test all kinds of contracts. However, it doesn't solve the backtesting step. It's kind of slow because it takes time to go through a long time period. And that's why we come up this tutorial is to use spot times to go through the backtesting. So as the file I'm going to demo is test me spot times. A few things we need to talk about is data provider name. In this demo, I use local file. However, use backtesting spot time system does not need to go with local file. You can go any other data providers, but I just use local file for demonstration because it's much faster. Since I'm using local file, I need to follow the setup to upload historical data from local file, which means I need to come up HistIngestionPlan, add individual plans, and specify the file names here. So we have talked about that already. And in this tutorial, I'm going to focus on this part of code to explain what's going on there. So think about in the previous tutorials, if we go back 50 days, literally the backtester will start from this time and go through the backtester minute by minute, even when the market is closed. For example, let's say 6 p.m. Eastern Time. The market is closed at 4 p.m., but the backtester still create a list of minute bar datas, whatever trading day or not, either morning or afternoon or evening, and the whole minute bar goes through the backtester, even if it doesn't mean a lot in our buy low sell high strategy, because in buy low sell high strategy, the transaction only happens at 3:59. For other minute bar data, we just waste. We don't use them. They are valuable, of course, but we don't need them for the strategy. So that's the improvement part comes in, which means if we can designate the spot times which the strategy really need, then we can save a lot of backtesting time. That's the idea comes from. So that in IBridgePy Backtester, we come up a special way to designate spot time to simulate strategies. The first thing is time generator type equals to custom, which means we will not use the default time generator, but we will generate by ourselves. So time generator type is a reserved word in IBridgePy. So set it to custom. Then, because this is custom, we need to supply a list of spot times that will go through the backtester, go through the strategy. And we use custom spot time list. This is also a reserved word in IBridgePy system, and its type is a list, Python list. The next one is, in this demo, I'm going to use pandas data range to create a list of spot times. That's why I need to import pandas as PD to use. And then date range is a list of spot times, which is created by a pandas function called data range. The data range, I need to designate start time, end time. Frequency 1D means I just want the daily data, want the daily, so which means October 30th, November 1st, November 2nd. This function will not consider trading days or weekends. And so we still created more than we need, but it's much less than backtesting every minute already. TZ means time zone. We need to specify the time zone of spot times. And PyTZ is a Python package to help to designate time zone for date times. So pytz.timezone is how we designate a time zone for date times. We specify the created spot times within the time zone of US Eastern. Because in our strategy, we follow US Eastern markets in US Eastern time zone. So that this is a list of custom spot times already. Then we use a for loop to put every time created in this date range into custom spot time list. So you can see we go through the list, and a day means it's created by this function. This function, because it's a day range, date range, so which means the value is a date. Not actually, I should change this to a date instead of, okay, it's called a day. It's okay, I think. So it's a date. And what I want to replace, because this one, if I don't change anything, the hour minute will be 00, because this one is just purely a day. And hour minute will be 0. However, in my strategy, I only care about 3:59 in the afternoon. So that I need to replace the hour and the minute by 15:59 in a day, and I call it A at this time. So after the change, it will become date time, something like 2020, 10, 30, and then 15:59. And all other times will be changed to 3:59 p.m. And then we use a Python list function called append. Append individual date time to the list. If we can print out this one, let's print out and just check what's going on there. And then that's all you need to specify, designate individual spot time to go through Backtester. And then let's run it. The test will be pretty fast. Nope, done. I will do the demo, change to Interactive Broker as the data provider. You will see this is much faster already. So let's take a look about what's going on there. So first, we print out the list. I want to show you what's inside this list. You can see October 30th, 15:59, 31st, 15:59, 15:59. The reason for 15:59 is we use this line to replace 00 by 15:59. So every spot time here is 15:59 already. You can see everything there because we print out here, but we really don't need to. And then because we load historical data from file, then it tells us we are loading historical data from input folder and the file name, and the bar size is a minute bar, SPY. To confirm data is correct, first line of data, last line of data is here. Then daily bar data, this one is daily. The first bar is, the last bar is this one. You can see for daily data, when we ingest them, you can see the hour is 00 and the minute is 00. So which means that's the tradition to define a date instead of a date time. So this line is to change the date to a date time there. And then backtesting started. We can see it goes through we can see the first one is not October 30th because October 30th is weekend. And the first trading day in this backtesting time period is November 2nd and started. And the transaction happened, bought 285 shares and the price goes to, and then we can see the last simulated transaction happens on December 23rd, 3:59 in the afternoon. SPY sold to, okay, 286 and the price. That's the simulation completed. And then we switch to an IBridgePy tool to visualize the account performance. What we are going to use is tools, go to portfolio, sharp ratio, and then we use this function, use latest backtest balance log. And this one is because in our backtester, two files will be created in the output folder. One is called balance log. The other one is called transaction log. In the balance log, it tells you what's the account balance, this column, is at the beginning of a day. And this is date, time, and the account balance. The other log is transaction log. It records each transaction here. They are as same as you see in this part console. And in this tool, this function reads in the latest balance log. You can check. This is the latest balance log is this one. It will read in it and make a plot. Also, to calculate annualized Sharpe ratio. If you want to know more about this part, you can go through the tutorials, our tutorials. I will talk about it later. And then let's run this one. This one is Sharpe ratio 2. Let's run it. Okay, you can see the annualized Sharpe ratio is 4.4, and the account performance starting from $100,000 and goes up. The default value in Backtester is $100,000, and it just like this. And this is the spot time. I used the historical data from my local file and go through the backtester and only go through the designated spot time to simulate the strategy, because that's the spot time I need in my strategy buy low, sell high strategy. And as the next demo, I want to change it to IB. This time, I will not supply historical data. I will just read historical data from Interactive Broker's server. You will see the backtesting will become much slower, even if we just designate a list of backtesting times. Let me just start it and comment out this one and switch to test me spot time and start. While it's running, you can see it continuously requests historical data from interactive broker, and it just goes to November 11th. So compared to use the historical data from local file to get data from brokers, the big difference is the time. It takes time to send out request to interactive brokers and then got a response from servers. This one takes much longer. Even if we just used designated spot times for backtesting, the slowest part is still retrieving historical data from brokers go through internet. So which means if you want to have a faster backtesting, the best way is to prepare historical data before backtesting, save them to local file, and then use local files to supply historical data. Also, if you want to speed up the process, um, so you know your strategy so that you can designate only the spot time that our strategy needs to go through backtester, and backtesting will become much faster compared to this one. You can see it takes time, still not finished, and the time still goes through December 1st, and it still need to run a little bit. Let's wait for a little bit. Stopped recording for a while because request historical data from interactive broker, it really takes time. Even if the backtesting go back 50 days and we did some speed up, but still slow, but finally it's there. And let's quickly take a look about simulation. We can see the data injection starts completed. Nothing happened because we didn't prepare historical data before backtesting. And you can see the warning message said we don't have daily bar data, so that IBridgePy has to request historical data, and we can see IBridgePy has to request 1 minute bar data at this spot time to continue, and recommend to add HistIngestionPlan in test.me file. And as a comparison, we want to visualize the testing result. And you can see the result is like this, very similar to the backtesting result with before. You can see the chart is pretty much same. Right? Okay, so this is the comparison. In summary, actually, what I want to demonstrate is the custom spot time does not need to upload historical data from local file. You can use any data providers actually. The real-time demo. It's time to talk about what's the pros and cons of this backtester setup. This backtester setup, the goal is to speed up backtesting by designating spot backtesting times going through the backtester. And the motto is backtest only the spot times that strategy needs. The pros of this setup is backtester is much faster because we removed unnecessary iterations in the code by just designating spot times going through the backtester. It's much faster. We only test what we really need. Also, combining with loading historical data from local file, we can use any historical data from any data sources so that you can test anything you have historical data. The cons of this backtester setup, there's still some disadvantage we need to improve. One thing I can think of is we still need minute bar historical data to supply to the backtester. If you have the access of minute bar data, that's not an issue. However, sometimes we really don't have minute bar data. For example, even for SPY, go back to maybe 20 years, it's still very hard to find the minute bar data, or it costs a lot of money to purchase minute bar data. But think about minute bar data go back 20 years is a lot of data. So we need to come up with a way to backtest when we don't have minute bar data. So that's a compromise, actually. If we have minute bar historical data, our backtesting result will be much more accurate than without minute bar historical data. So the improvement is we can simulate minute bar when we really want to do some backtesting, but we still don't have the minute bar data available. The solution for this one is we're going to have a IBridgePy data source, so that IBridgePy will simulate minute bar data for backtesting. As I explained, the minute bar data is simulated from other time frames, for example, daily bar, which means the simulated minute bar is not accurate anymore. And the backtesting result is definitely not as good as the real minute bar data. However, that provides a convenience for users to have a feeling about the strategy. So we will have more tutorial to talk about using IBridgePy data source for backtesting later. YouTube tutorials for you to understand these topics. For example, the first one you can consider to watch is this tutorial is how to build buy low, sell high strategy by machine learning skills. The other one is we have a detailed explanation about the coding part of buy low, sell high strategy in IBridgePy, so you can understand more details there. For the performance analysis, we have a tutorial to talk about what is Sharpe ratio and how to calculate the Sharpe ratio of the backtest results in IBridgePy Backtester. So you can refer to this tutorial to do that. Also, we have this tutorial, which is the easiest default backtester setup, so that you don't need to import any historical data. You just run it, and IBridgePy Backtester will retrieve historical data from interactive brokers. If you want to speed up the backtesting process, you can ingest historical data before the backtesting. You can refer to this tutorial. Also, IBridgePy Backtester supports backtesting from loading historical data from local files. You can refer to this tutorial. Backtester has some special data format. So for some cases, especially when you want to import historical data from other data providers, you may need to convert historical data format a little bit to fit IBridgePy Backtester format. You can refer to this tutorial to understand what IBridgePy tools provide you to convert historical format.
Thank you very much. For any questions, please send email to ibridgepy@gmail.com. If you need any help on coding, please check out our well-known Run a Coder service. More tutorials are coming. Please don't forget to subscribe. IBridgePy is an easy-to-use Python platform to backtest and live trading. Thank you very much.